Hiya! So we're going to do some more probability, this time something called expected frequency. But before that, let's just sort of check that we're happy with our just calculating normal probability. So here's a standard deck of cards. Using these cards only the ones you can see, calculate these probabilities of, let's say I take a card at random, what's the chance that, for example, what's the probability that it's a card with a number on it? Okay, so pause the video, write out the questions, write out the answers, unpause when you're done. So first one, what's the probability it's a card with a number on it? Well, there are actually 9 cards that have numbers on. That's 2 to 10. It doesn't include the aces because they have no numbers, or Jack, Queen, King. So there's 9 cards for each suit. There are 4 lots of 9 because there are 4 different suits. That's actually 36 different cards out of a total of 52 cards. So the probability is 36 out of 52, or anything equivalent to that if you've simplified it. Right, what about the probability of a 10? Well, there's 1, 2, 3, 4 of those out of 52. Again, if you've simplified that, anything equivalent to that is fine. So 1 in 13 or 2 in 26. What about the probability of it being a club? Now the clubs are this suit here. I put a little symbol in case you didn't know. And there are 13 of those out of 52 cards, or you might have simplified it to a quarter. What's the probability it's a red card? Well, there's 2 suits that are red cards, and that's 26 out of 52. You might have simplified that all the way to a half, or anything equivalent to 26 out of 52, but a half is also fine. Joker, what's the probability of Joker? Well, I did say only these cards, and there are 0 Jokers in those cards. So 0 out of 52, which is also 0. Either of those is absolutely fine. There is impossible to pick a Joker out because there aren't any. So good. Let's talk about expected frequency then. So sometimes we want to know how many wins we may have from a set of trials. Now a trial is just like an event, like rolling a dice, or pulling a card out of a deck of cards, or pulling a coloured counter out of a bag of different coloured counters. That is a trial, just one trial. Okay. Now let's say we do a lot of trials. I pull a lot of cards out of the deck of cards. You know, how many times would I expect to win? You know, or to get my probability that I'm looking at. So, for example, we call this expected frequency. This is what expected frequency is. It's how many wins I would expect to get. Frequency in maths is another word for how many. So how many wins would I expect to get from this number of trials? Right, how do we calculate expected frequency? Well, for example, this is the sort of question we're talking about. Say we roll a dice, and by that we just mean a standard 6-sided dice. If I roll it 120 times, how many times would I expect to roll a 6? Now, the first thing I'm going to work out is what is the probability of getting this win. The win in this case is a 6. What's the probability of rolling a 6 on a dice? Well, there's 1 6 out of a total of 6 different numbers. There's a 1 in 6 chance of rolling that 6 on a standard fair dice. Now, with expected frequency, probability equals proportion, right? In this particular context, probability is proportion. Proportion is probability. It's the same thing. Now, if I expect, if the probability of getting a 6 is 1 in 6, then that's the proportion of times that I would expect to win. So I would expect 1/6 of 200 to be, my wins. Would I expect to get 6? Sorry, let's say it again. My win is to get a 6. I'd expect 1/6 of my rolls to be a 6. Now I don't know why I've written 200 there, because I meant it said 120, didn't it? So not only am I going to change the number to the correct amount, but I'm also going to change my of to a times, because in maths, of means times. So I want 1/6 of 120, and you can use a calculator for this. If I'm finding a fraction of amounts, you divide by the bottom times by the top. So 120 divided by 6 is 20. I would expect to get 20 wins. All right. Now, yeah, so if you were doing it on calculator, I would just type in the fraction, set your fraction up on your calculator, times by 200, oh, sorry, times by 120, just like I have written there, and it will give you your answer, this, yeah? Okay. Right, let's try another one. If I roll a dice 90 times, how many times would I expect to score less than 3? Well, what is the probability of less than 3? Well, there are two numbers that are less than 3 out of 6. So I would expect 2/6 of all of my rolls to be less than 3. So I want 2/6 of 90. Remember, of is times, so it's 2/6 times 90. So 90 divided by 6 times by 2. Or if you've got a decent calculator, put your fraction in, 2/6 times by the 90. And it tells me that it's 30. I would expect to get 30 rolls that are less than 3. So find the probability of your win, and that is the proportion of your amount that will be wins. So if you spin this spinner 100 times, how many times do you expect to spin a 4? Well, what's the probability of getting a 4 on this spinner? Well, there's 1 4 out of 4 equally sized space, so it's 1 in 4, isn't it? So that would be the proportion of times I would expect to get a 4. So I want that proportion of 100, 1/4 of 100. So I'm putting my fraction in, 1/4 times by 100 is 25. It's just 1/4 of 100. I expect to get 25 spins where I get a 4. Okay, try that out. There you go, there's some questions. I'd like to make sure you've got some good examples, so make sure you're writing down these questions and then answering them, please. So pause the video, unpause when you've done all that. If you roll a dice 60 times, how many times do you expect to roll a 5? Well, what's the probability of a 5? It's 1 in 6, because there's 1 5 on a dice out of 6 numbers. So that's the proportion of times I would expect to get a 5, and that's 10. 1/6 of 60 is 10. If I flip a coin 50 times, how many times would I expect to get heads? Well, firstly, what's the probability of a heads? That's a half. It's 1 in 2, because one side of a coin is heads, the other's tails. And so that's the proportion of times that I would expect to get a heads. So I'd expect if I flipped it 50 times, I'd expect half of them to be heads, 25. If I roll an 8-sided dice 40 times, how many times do I expect to get an 8? Well, in this case, the probability of getting an 8 will be 1 in 8, because there's only one of them on the dice. It's an 8-sided dice, so 1 out of 8. Now, that's the proportion of times I would expect to get an 8. So 1/8, 1 over 8 times by 40 equals 5. I would probably expect to roll an 8 5 times out of those 40. So remember to mark your work as well. Cool. What if it's not something that's quite so obvious? So it's similar though. So this spinner's got 5 equally sized spaces, but they've got different numbers in them. If I spun the spinner 20 times, how many times would I expect to get a 1? Well, the probability of getting a 1 is 1 in 5, because there are 5 equally spaced things and only one of them is a 1. So that's the proportion of times that I would expect to get a 1. So that's 1/5 of 20, which is 4. I would expect to get 4. What about if I spun it 40 times though? And how many times do I expect to get a 2? Again, work out the probability first. What is the probability of getting a 2 on this spinner? Well, there are 3 spaces that have got a 2 out of a total of 5. So the probability of getting a 2 is 3/5. So that is the proportion of times that I would expect to get a 2. Probability is proportion. So on here, I'm going to do my fraction of 3/5 times by the 40, which is 24. Remember, if you don't have a calculator quite like that, you could, if you're finding a fraction of an amount, you divide by the bottom times by the top. So 40 divided by 5 is 8, times by the 3 is 24. Divide by the bottom times by the top. Right, if you would spin the spinner 50 times, how many times you'd expect to spin a 3? Well, what's the probability of a 3? It is 1/5, because one of the 5 segments is a 3. And so that is the proportion of times that I would expect to get a 3. So 1/5 of 50 is 10. I'd expect to get 10 of them if I spun it 50 times. Cool. Here's a different spinner for you. 8 equally sized spaces with different numbers in. Different amounts of trials. You know, the trials are how many times you've done it. Again, you know, make sure you've got some good examples here. Pause the video, unpause when you've answered these questions, please. So we've unpaused. Let's look. If you spin this spinner 40 times, how many times you'd expect to spin a 1? Well, the probability of a 1 is 3 out of 8, because there are 3 of the 8 spaces that are a 1. So that's the proportion of times that I would expect to get a 1. So 3/8 of 40. Remember, you could divide by the bottom times by the top, or you can put it in your calculator just as a fraction times by 40. And it's 15. I would expect to get 15 wins there. What about if I do it 56 times? What's the probability of a 2? Well, only one of those 8 spaces is a 2, so the probability is 1 in 8. So that is also the proportion that are going to be 2s. So 1/8 of 56, so 56 divided by 8, or just times that fraction by 56. There are 7. I'd expect to get 7 times to get a 2. If I spun the spinner 60 times, what's the probability of getting a 3? Well, the 3, there are 2 sections that are a 3. So that's 2 in 8. So that's the proportion of times I would expect to get a 3. So I want 2/8 of 60, which is 15. I'd expect to get 15 of them. What about if I spun it 100 times? What's the probability of a 4? Well, there are 2 sectors again, which are a 4, so 2 out of 8. So that's the proportion of times I'd expect to get a 4. So I want 2/8 of 100, which is 25. I would expect to get 25 4s if I did it 100 times. Cool, okay, that's pretty straightforward, isn't it? Here's another question for you. This time is a game of chance, and there's the probability of winning either a 20p or a 50p or 100 or £1. Now, it doesn't tell us what the game is or what I do for it, but what it does do, there's a little table here that tells me what the probability is of winning each of these amounts, and each of the questions tells you how many times it's going to do it and the amount it wants you to win. So you've got the probability, you've got the amount of trials. Should be quite straightforward, okay? You don't necessarily need to copy this question out, but do answer it fully and then unpause when you're done. So, what's the probability of getting a 20p win? Well, that's 0.1. So, that's the probability. It's also the proportion. So, I need to do 0.1 times by 50, because that's the amount of times that we're playing the game in this case. So 0.1 times by 50 is 5. I'd expect to win 5 20p's. Hope you got that. What's the probability of winning 20p if I do it 75 times? Well, again, the probability is 0.1, isn't it? So that's the proportion of times I'm going to win 20p. So 0.1 times by 75 equals, okay, well, we get a decimal here, which is 7.5. Now, how many times do I expect to win? Unfortunately, we need to have a whole number, so we round it to the nearest whole number, because I can't have half a win. It's either a win or a lose. So I'd expect to get about 8. Okay, now I've put this a little approximately equals to sign in there. Now again, this is 20p again, so the probability is the same. So that's the proportion of times I'd expect to win, which in this case is 9. So if I did it 90 times, I'd expect to win 9. Okay. Let's have a look at this though. What about this? I've got a game at a fair that involves rolling a 10-sided dice. Fair enough. It costs 20 pence to play the game, and if you roll a 10, you win a pound, right? So the win here is rolling a 10. And I get a pound if I do that. So sounds fair enough. Only 20p to play. If 200 people play the game, how many would I expect to win? Okay, well, let's see. What's the probability of rolling a 10 on this dice? Well, it's 1 in 10, isn't it? Because it's a 10-sided dice and there's only one 10 on it. So that's the proportion of times I'd expect people to win. There are 200 people playing it. So I would expect 20 people to win. How much money would let's just cross that out, would you need to give out in winnings? Well, if all of those 20 people wins a pound, that's going to be 20 lots of a pound, which is, of course, 20 pounds. That's how much money I'd expect to give out. And how much profit would the game make? Oh, well, that's a different question. What is profit? Well, profit is when you work out how much something has cost to produce, and then you take away how much income you get from, say, selling it, then what's left over is profit. So firstly, I need to work out how much income I have from the game. So my income is all the 20p's, right? So I've got 200 lots of 20p, which is 4,000 pence. Well, let's change that into pounds. That's going to be £40. I guess that's not very neat, is it? I need space for my pound sign. So there's my income. It's just the number of people playing times by the amount they're paying. They're paying 20p. So 200 lots of 20p is £40. Now my costs. What's the cost in this game? Well, the cost is I need to give out the winnings. Now my winnings was the 20 lots of £1, wasn't it? If 20 people win, they get a pound each. So the total I have to give out is £20. So my profit is the difference between the two. So I have my income, and I take away from that the amount of money I need to give away. And what's left over, which is £20, is my profit. So that's what profit is. Difference between the income and the cost, the outgoings. Yeah. Okay, similar question for you to have a go. That's quite structured quite similarly to help you out here. It's a good idea to maybe copy this question out, including the spinner, just so you've got something to work from. A game at a fair involves spinning the spinner. It costs 50 pence to play the game. And if you spin a 3, you win a pound. In the meantime, I'm going to go and answer the phone. Pause the video. Unpause when you're done. Well, we've unpaused, and I tried answering the phone, but whoever it was didn't want to speak to me. So, never mind. Okay, a game at a fair involves spinning a spinner. It costs you 50p to play. If you spin a 3, you win a pound. So firstly, if 300 people play, how much would you expect to win? Well, what's the probability of getting a 3? It's 1 in 5, because one of the segments out of 5 is a 3. So that's the proportion that will win. Well, we'd expect to win, because it's all about theoretical probability, isn't it? It's what do we expect to happen? So that's 1/5 of 300, which is 60. I'd expect 60 people to win. God. How much money would you need to give out in winnings? Well, each of those 60 people gets £1. So I'd expect to have to give out £60. So how much profit would I have? So income first. What is my income? Well, there are 300 people playing the game, and each pay 50 pence. Well, that's a total of £150 income. What are my costs? Well, there are 60 people that are going to win, or I'd expect to win, and they each get a pound. So that's £60 of costs, and then I haven't left myself much space for the profit, but thankfully it's easy to do. So my profit is the difference between my income of 150 and my expenditure of 60, and so my profit would be £90. Hopefully giving away to charity. Maybe for donkeys. So here's another game of chance, and you can win different amounts this time. And well, the question's pretty self-explanatory. Pause the video, unpause when you're done. Unpaused. Right, if 200 people play the game, how many would you expect to win each amount? Right, let's give ourselves a bit of space here. So, what's the probability of winning 20p? Well, that's 0.1. The probability of winning 50p is also 0.1. And the probability of winning the pound is a bit smaller, 0.05. And 200 people are playing, so I'd expect 0.1 times by 200 people to win 20p, 0.1 of those 200 to win 50p, and 0.05 of those 200 people to win the pound. Now, I'd expect 0.1 times 200 is 20 people for the 20p, same for the 50p, but 0.05 times 200 is 10 for the pound. I'd only expect 10 people to win the pound. And just out of interest, if we add those up, that's 50 people in total to win that are going to win. Sorry, 50 people that are going to win in total. Now, if 200 people play the game, right? So B, how much money in total would you need to give out in winnings? Okay, so we've got 20 people winning 20 pence. So 20 lots of 20 pence is £4. I've got the same number of people winning 50 pence, so that's £10. And then I've got those 10 people that are winning £1 each, so that is also £10. So how much would I need to give out in total? That's the total of these, which is £24. So that's the part to B. That's £24. Oops, that's 20 there, 24. If it costs £1 to play the game, how much profit would I make? Now, to keep things clear, because I've been a bit messy with my writing here, I'm just going to change colour. If it costs £1 to play the game, how much profit would it make? So I need to know my income. Well, that's 200 people playing, each paying £1. So that's £200 income. What are my costs? Well, I've already worked that out. That's all the winnings I need to give out, which is a total of 24. And so my profit is the difference between the two. The 200, take away the 24, which equals £176. Yep. Oops. Cool. Nice one. Well, I hope you got the idea of those sort of games. So there's a couple of quick fire questions, just two of these. These are kind of straight back to the more kind of straightforward questions you get. And this is the sort of thing you might get in a test, obviously. So pause the video, unpause when you've done this question. Well, a bag contains 12 balls and 3 of them are black, 4 are blue and the rest are red. A ball is drawn at random, as in pulled out at random, the colour noted, and then it's replaced. And this is done 144 times, so 144 trials. How many times do you expect to get a red ball? Well, how many reds are there? 12 is the total. Take away the number of black. Take away the number of whatever the other one was, blue. And what we're left over is how many reds there must be. So there are 5 red balls. So what's the probability of getting red? It's 5 out of 12. How many times do I expect to get a red ball? Well, that is the probability, so that is also the proportion, because probability is proportion in this case. So I want 5/12 of 144. And again, you could divide by the bottom times by the top, so divide by 12 times by 5, or just put it in your calculator like I've written here. And there are 60. Oh, I didn't undo my pause, did I? Oh, silly me. But there are 60 anyway. Mark your work. And move on to the next quickfire question. Probabilities of winning different amounts of money in a game are shown here. 20p, 50p and a pound. Different to what we had before though. if you played the game 200 times, how many times, should be plural, would you expect not to win anything? So not to win. Remember what probability adds up to, and unpause when you're done. Okay, two ways you can do this. So I'm going to split my screen down here. The easy way and the longer way. Let's show you the longer way first of all. If I played it 200 times, how many times do I expect to win? So you could work out, obviously, the wins, right? You could do 200 times by 0.15. That'd be the number of times that I'd expect to win the 20p. Well, that's 30. It would be 200 times by 0.08 for the 50p. There is a much quicker way of doing this, by the way, which I'll show you in a second, which is 16. And then, of course, you want to know the wins for the pound, which is 0.05, which is 10. Add them all up, which is 30, 16, and 10, 3, 4, 5, 56 wins. So, if we're doing it 200 times, 200 take away 56 is 144. That's how many times I would expect not to win. So I worked out all the numbers of wins I would do, took that away from the total, that's how many. But here's another way. Why not add up your probabilities that you've got here and see what you get? So 0.15 plus 0.08 plus 0.05 is 0.28. Now probabilities always add up to 1. So if I do 1, take away the probability of winning, what I'll be left with is the probability of losing. So the probability of lose equals 0.72. So that will be the proportion of times that I'm going to lose, because probability and proportion are the same thing, and what you know, it equals the same answer, because, you know, it's the same question. Just different way of doing it. Two different ways of doing the same question. Okay? Right then, well done. Go off and do some Dr. Frost if there is any. Otherwise, I'll see you again next time. Bye-bye.